All right, so today is our last distance learning lesson. Next week you'll have your review sheet on Tuesday and then test on Thursday, and then we'll be done for the year. Today we're going to talk about some applications of logarithms, and the most common one is with exponential growth or decay. All right, when we graphed exponential functions earlier, we know that growth is something that starts low and then gets really big. Where there'd be a horizontal asymptote somewhere, and decay would start really big and then level off at some asymptote. So we're talking about things in real world situations where the price goes up, or maybe the temperature goes up, or the population goes up and keeps growing, and then things that also decrease as well. So taking a look at the equation, you may recognize this equation a little bit. It looks similar to one we've talked about, which I'll mention in a second. So the equation is y equals y sub 0, okay? And I know some of you are in physics, so like v sub 0 is the initial velocity, y sub 0 is the initial amount. And then e, remember, is just the button on your calculator, 2.718, raised to the k times t. Okay, so if you think about it, that looks a lot like the PERT formula. Where P was your initial amount, and then it's E, and then the rate times time, where that time is in years. So there's a few differences here. When we talked about PERT, that rate always had to be positive. So when we talk about growth and decay, if K is bigger than 0, it's going to be exponential growth. But if K is negative or less than 0, that means your whatever you're talking about is decreasing, so it's exponential decay. Also, the T, the time, could be in minutes, hours, seconds. That time can change based on the problem. All right, so taking a look at the first one, it says the number of bacteria present in a culture at a time T, where it says times in hours, obeys the model given. So we've got N, which is just the number of bacteria. Remember, N sub T, you don't plug T in. Remember, that's similar to f of x. So that's basically just saying N, but it's a function, is equal to 1000 e to the 0.01 t. So if we're looking for the initial number of bacteria present, that's going to be that y sub 0 right in front. So I know that we're starting with 1,000 bacteria. We know that it's growth because that rate is positive up there. But if we're looking for the growth rate, the decimal is 0.01, but if we move it twice, the growth rate is actually 1%. Okay, and then it asks for the population after 4 hours. So we're going to say N is equal to 1000 e to the 0.01. And since time was in hours, we're just going to multiply that by 4. All right, so we need to go to our calculator, open that up, and we're going to do 1000. Second ln gives us that e to the 0.01 times 4. If you have an older calculator, you're going to have to put that 0.01 times 4 in parentheses. If you get that little caret symbol, or like it looks like part of an arrow. And then I hit enter, and now it's at, we'll just round to the nearest whole number, 1041. So now the bacteria is 1041. Okay, the next one says, when will the bacteria reach 1700? So just like with the PERT formula, that N sub T is that final amount, or N of T is that final amount. We want that final amount to be 1700, and that's going to be equal to 1000 e to the 0.01. And excuse me, since it says when, we're looking for time, so we're going to multiply by T, because time is what we're solving for. So just like we did yesterday, or last lesson, you're solving for something that's up in the exponent. So the first thing I need to do is I need to get rid of the 1000. Okay, that divides nicely. That gives us 1.7 e to the 0.01 t. Now that equation is an exponential equation, so to solve it, we're going to have to put it into log form. So it's going to be log base e of 1.7 equals 0.01 t. Well, we know log base e is just ln, so it's ln of 1.7 equals 0.01 t. So we're going to have to do natural log of 1.7, hit enter in our calculator, and divide that number by 0.01. So we go ln of 1.7, hit enter, and divide by 0.01, and that gives us about 53 years. So again, I'm just going to round to the nearest whole number. So time is approximately 53, oh, not years, our time was in hours, so we got to make sure we label it properly. So it's 53 hours. All right, the last one says, when will the bacteria triple? So we know we started with 1,000 bacteria. So just like we did with the money yesterday, if we're going to triple that, now it's going to be 3,000. Okay, and we're going to solve it just like the last one. First step is to divide by 1,000. So we get 3 equals e to the 0.01t. Okay, then in order to solve an exponential, we got to switch it to log form. So it's log base e of 3 equals 0.01t. We know log base e is just ln, so that's ln of 3 equals 0.01t. So again, we're going to have to go back to our calculator, and we're going to have to do ln of 3, hit enter, divide by 0.01, and that gives us 110 hours. So time is 110 hours. And again, I'm just rounding to the nearest whole number. Make sure that you round to the nearest whatever it asks you in your worksheet tonight. All right, so our last one is strontium 90. Okay, so ignore the 90. Strontium 90 is just what that radioactive material is called. It's decaying at a rate of 2.44%. And we're going to assume that a scientist has 500 grams. So again, our equation is, we can do just y equals y sub 0 e to the kt. So in this case, if we're looking at our numbers, we get y equals, we start with 500. That's our y sub 0 is our initial amount. E is always in the equation. Now here's where we have to be careful. It is a decay problem. So when we said decay, we know that that rate or that k value has to be less than 0. It says it's decaying at 2.44%. So that's going to be negative 0.0244. So this is where you have to be really careful. If it's growth, it's positive. If it's decay, it's negative, and then that t. So there is our equation. So the first question I'm asking is, how much is left after 10 years? So that's pretty straightforward. We just do 500 e to the negative 0.0244 times 10. So just plug in 10 there. So we go to our calculator and we do 500 second ln, which is e, negative 0.0244, and we said 10. And it is down to 391. I'm just going to go 391.7. Okay, so it's 391.7, and that is grams because we started with 500 grams. And that should make sense. The problem says it's decaying, so we started at 500, now we're down to 391. Okay, the next one says, when will 400 grams be left? So that means my y value has to be 400, so it's 400 equals 500 e to the negative 0.0244t. And just like we did on the last problem, our first step is to divide by 500. Okay, that gives us 4/5. Or you could plug it in to your calculator and get a decimal too, that's okay. It is a nice decimal though, so you don't have to use that second enter button. So I get e to the negative 0.0244t. Switch it to exponential, or I'm sorry, switch it to log form. So it's going to be log base e of 4/5 equals negative 0.0244t. Remember, log base e is just ln, negative 0.0244t. Ln of 4/5. So we're going to have to go to our calculator, and we're going to type in this time ln of 4/5. Hit enter. Notice it's negative. We're going to divide by negative 0.0244. Hit enter. We get about 9. I can't remember what it was. So we get t is, if we round to the whole number, 9. And in this case, it was per year. So our time is 9 years. And if you think about it, it took 10 years to get 391. So it's going to take a little less to end up with 400. So that just makes sense, makes common sense. And then the last question talks about the half-life. So we've been doubling and tripling in some of our problems. Now we're going to talk about something that's decaying, so it's not going to be able to double and triple if it's going down. So if we start with 500, and if it's half-life, that goes to 250. e to the negative 0.0244t. So when we solve, just like we did on the last one, we're going to divide by 500. So it's 1/2 equals e to the negative 0.0244t. Okay, so then again to solve, we're going to switch it to log form. So it's log base e of 1/2 equals negative 0.0244t. Log base e is just ln. Okay, so again, in our calculator, we are going to do ln of 1/2 or 0.5, and then we're going to have to divide by negative 0.0244, and I get about 28.4, so we'll just call it 28. So t is approximately 28 years. All right, so your homework tonight is a worksheet. That is your last assignment other than the review sheet. So this is the last day of new material. Don't forget that I'm hosting a Zoom session at noon today, so feel free to jump on there if you've got any questions. I'll do another one on Tuesday next week prior to the test, so if you've got any questions there. Otherwise, it's crazy to think that we've only got 1 week left, but we're almost there, so keep working. Go back and make up any homework assignments or quizzes or tests. Email me for those of you that have missed some of the assessments because we are getting close to wrapping up. Thanks. Have a great day.